Two capacitors of capacitances 0.3 microfarad and 0.6 microfarad are connected in series across a battery of 6 volt. The ratio of energies stored in them is option A 1 by 4, option B 1 by 2, option C 2, option D 4. Correct answer option C 2. The number of electrons to be put on a spherical conductor of radius 0.1 meter to produce an electric field of 0.036 Newton per Coulomb just above its surface is option A 2.7 into 10 raised to the power 5, option B 2.6 into 10 raised to the power 5, option C 2.5 into 10 raised to the power 5, option D 2.4 into 10 raised to the power 5. Correct answer option C 2.5 into 10 raised to the power 5. Separation between the plates of a parallel plate capacitor is D and the area of each plate is A. When a slab of material of dielectric constant K and thickness T less than small d is introduced between the plates, its capacitance becomes option A epsilon naught A upon D plus T into 1 minus 1 upon K. Option B epsilon naught A upon D plus T into 1 plus 1 upon K. Option C epsilon naught A upon D minus T into 1 minus 1 upon K. Option D epsilon naught A upon D minus T into 1 plus 1 upon K. Correct answer option C epsilon naught A upon D minus T into 1 minus 1 upon K. The capacitance of the earth viewed as a spherical conductor of radius 6408 km is option A 600 microfarad, option B 712 microfarad, option C 980 microfarad, option D 1424 microfarad. Correct answer option B 712 microfarad. 4 capacitors, each of capacitance 4 millimicrofarad are connected as shown. The energy stored in the system is option A 1.8 ergs, option B 2.4 ergs, option C 3.6 ergs, option D 5.4 ergs. Correct answer option A 1.8 ergs. A parallel plate capacitor of plate area A and plate separation D is charged to potential difference V and then the battery is disconnected. A slab of dielectric constant K is then inserted between the plates of the capacitor so as to fill the space between the plates. If Q, E and W denote respectively the magnitude of charge on each plate, the electric field between the plates after the slab is inserted and work done on the system in question in the process of inserting the slab, then option A Q equal to epsilon naught AV upon D, option B Q equal to epsilon naught KAV upon D, option C E is equal to V upon KD. Correct answer option A Q equal to epsilon naught AV upon D and option C E is equal to V upon KD. The separation between the plates of a parallel plate capacitor is D. A metal slab of thickness D by 2 is inserted between the plates. The ratio of the capacitances before and after the introduction of the slab is option A 1 is to root 2, option B root 2 is to 1, option C 1 is to 2, option D 2 is to 1. Correct answer option C 1 is to 2. Two spheres A and B having radii 5 cm and 10 cm respectively are carrying charges of plus 10 Coulomb and plus 20 Coulomb respectively, distributed uniformly. Their centers are separated by 80 cm. The electric field on the line joining the centers of the spheres will be zero at a distance from the center of A equal to option A 20 cm, option B 33 cm, option C 47 cm, option D 60 cm. Correct answer option B 33 cm. A capacitor of capacitance 1 microfarad can withstand a maximum voltage of 6 kilovolt, and another capacitor of capacitance 2 microfarad can withstand a maximum voltage of 4 kilovolt. The series combination of these two capacitors will withstand a maximum voltage of option A 4 kilovolt, option B 6 kilovolt, option C 9 kilovolt, option D 10 kilovolt. Correct answer option C 9 kilovolt. The capacitance of a spherical capacitor is 1 microfarad. If the spacing between the spheres is 1 millimeter, the radius of the outer sphere is option A 3 centimeter, option B 30 centimeter, option C 6 meter, option D 3 meter. Correct answer option D 3 meter. An infinite number of identical capacitors, each of capacitance 1 microfarad, are connected as in the figure. The equivalent capacitance between A and B is option A 1 by 2 microfarad, option B 1 microfarad, option C 2 microfarad, option D infinite. Correct answer option C 2 microfarad. The capacities of two conductors are C1 and C2 and their respective potentials are V1 and V2. If they are connected by a thin wire, then the loss of energy will be option A C1 C2 into V1 plus V2 upon 2 C1 plus C2. Option B C1 C2 into V1 minus V2 upon 2 C1 plus C2. Option C C1 C2 into V1 minus V2 का whole square upon 2 C1 plus C2. Option D C1 plus C2 into V1 minus V2 upon C1 C2. Correct answer option C C1 C2 into V1 minus V2 whole square upon 2 C1 plus C2. A capacitor of capacitance C has charge Q and stored energy is W. If the charge is increased to 2Q, the stored energy will be option A W by 4, option B W by 2, option C 2W, option D 4W. Correct answer option D 4W. 5 capacitors are connected as shown. The equivalent capacitance between A and B and the charge on the 5 microfarad capacitor will be respectively option A 4 microfarad and 50 microcoulomb, option B 8 microfarad and 100 microcoulomb, option C 12 microfarad and 150 microcoulomb, option D 16 microfarad and 200 microcoulomb. Correct answer option A 4 microfarad and 50 microcoulomb. Between the plates of a parallel plate capacitor, a plate of thickness T1 and dielectric constant K1 is placed. In the rest of the space, another plate of thickness T2 and dielectric constant K2 is placed. If Q is the charge on the capacitor, then the potential difference between the plates is option A Q upon A epsilon naught into T1 upon K1 plus T2 upon K2. Option B Q upon A epsilon naught into K1 upon T1 plus K2 upon T2. Option C epsilon naught Q upon A into T1 upon K1 plus T2 upon K2. Option D epsilon naught Q upon A into K1 upon T1 plus K2 upon T2. Correct answer option A Q upon A epsilon naught into T1 upon K1 plus T2 upon K2. The radius of a hollow metallic sphere is capital R. If the potential difference between its surface and a point at a distance of 3r from its center is V, then the electric field intensity at a distance of 3r from its center is option A V upon 2r, option B V upon 3r, option C V upon 4r, option D V upon 6r. Correct answer option D V upon 6r. Two charged metallic spheres of radii 20 cm and 10 cm have 150 microcoulomb positive charge each. If they are connected by a conducting wire, then the common potential will be option A 9 into 10 raised to the power 6 volt, option B 4.5 into 10 raised to the power 6 volt, option C 1.8 into 10 raised to the power 7 volt, Option D, 13.5 into 10 raised to the power 6 volt. Correct answer, option A, 9 into 10 raised to the power 6 volt. The insulation property of air breaks down when the electric field is 3 into 10 raised to the power 6 volt per meter. The maximum charge that can be given to a sphere of diameter 5 meter is approximately option A, 2 into 10 raised to the power minus 2 coulomb. Option B, 2 into 10 raised to the power minus 3 coulomb. Option C, 2 into 10 raised to the power minus 4 coulomb. Option D, 2 into 10 raised to the power minus 5 coulomb. Correct answer, option B, 2 into 10 raised to the power minus 3 coulomb. In the given circuit, the potential difference across the 4.5 microfarad capacitor is option A, 8 by 3 volt, option B, 4 volt, option C, 6 volt, option D, 8 volt. Correct answer, option D, 8 volt. Two capacitors of 3 picofarad and 6 picofarad are connected in series and a potential difference of 5000 volt is applied across the combination. They are then disconnected and reconnected in parallel. The potential difference across the combination is option A, 2250 volt, option B, 1111 volt, option C, 2.25 into 10 raised to the power 6 volt, option D, 1.1 into 10 raised to the power 6 volt. Correct answer, option B, 1111 volt. In the given circuit, the potential difference across the 7 microfarad capacitor is 6 volt. Then option A, the potential difference across the 12 microfarad capacitor is 10 volt. Option B, the potential difference across the 3.9 microfarad capacitor is 10 volt. Option C, the charge on the 3 microfarad capacitor is 42 microcoulomb. Option D, the EMF of the battery is 30 volt. Correct answer, option A, the potential difference across the 12 microfarad capacitor is 10 volt. Option C, the charge on the 3 microfarad capacitor is 42 microcoulomb. Option D, the EMF of the battery is 30 volt. When two capacitors are charged to different potentials and then connected parallel to each other, the net option A, charge equals the sum of the initial individual charges. Option B, potential difference across them equal the sum of the initial individual potential differences. Option C, potential difference across them is different from the sum of the initial individual potential differences. Option D, energy stored in the combination is less than the sum of the initial individual energies. Correct answer, option A, charge equals the sum of the initial individual charges. Option C, potential difference across them is different from the sum of the initial individual potential differences. Option D, energy stored in the combination is less than the sum of the initial individual energies. In the figure, the equivalent capacitance between A and B is option A, 3.75 microfarad, option B, 5.25 microfarad, option C, 6.5 microfarad, option D, 10.5 microfarad. Correct answer, option A, 3.75 microfarad. In the given circuit in steady state, option A, the potential difference across C1 is 10 volt. Option B, the potential difference across C2 is 10 volt. Option C, the charge on C1 is 20 microcoulomb. Option D, the charge on C2 is 8 microcoulomb. Correct answer, option B, the potential difference across C2 is 10 volt. And option C, the charge on C1 is 20 microcoulomb. In the given circuit, the potential difference between A and B is option A, 0, option B, 10 volt, option C, 14 volt, option D, 16 volt. Correct answer, option D, 16 volt.